All right, so let's talk through the analysis of this algorithm in deterministic MDPs. I'm going to call the algorithm Rmax because anything we don't know we assume is Rmax. It's not a great name, I guess, but it is the name that it was given by Brofman and Tenenholtz when they first proposed and analyzed it. I guess it had another name too.
Armin?
No, because the algorithm actually is directly related to an algorithm that Andrew Moore proposed but didn't have an analysis for it.
So it could have been Armor.
I see. Rmax, and even more than that is Rmore.
Mm-hmm.
All right, let's just go with that. So here's the algorithm. I just copied it from the previous slide. And there's some things that we can figure out about this, like once we've actually visited all the state action pairs in a deterministic MDP, then this algorithm is going to be perfect. It's never going to make any more mistakes after that. Right? Do you see that? Because it's going to, in step 3, it solves the MDP, which is in this case now the actual optimal policy. And then any action that it takes from that policy thereafter is going to be an optimal action, not a mistake. So this is great. If it's the case that we eventually visit all of the edges in the MDP, then we'll make no more mistakes after that point.
How do you count mistakes, though? You count mistakes on a per-state basis?
Yeah, a mistake in this case means I'm in a state, I take an action, and that action wasn't near optimal from that state.
From that state, right.
All right, so but we need a couple more things here, right? So it could be that we never actually know the whole MDP.
That's possible. For example, if we're in one of those trap states.
What happens if we stop visiting unknown states, right? So what would that mean? In the case of a deterministic MDP, it would mean that we're following some policy that is taking us on edges that we know about. And this is so nothing new ever happens, nothing new is ever learned. But there could be other unknown edges elsewhere in the MDP that we're not visiting. So could we be making mistakes as we go around this loop over and over and over again?
If we can get to that state from any of those states, then we would end up going to that state because we assume it's the best thing that we could do.
Not necessarily.